Hey, good evening, everybody. This is Rick Alling, and I wanted to welcome you to our, let me see, this is August the 10th, our August 10th version of Virtual Night Sky. I got a lot to talk to you about tonight. We've got a lot going on, but I wanted everybody to say hi to Luna before we sort of start. We're on vacation. Luna and I and my wife are in Santa Fe, New Mexico, and Luna's wearing a sporty little sort of kerchief today. So I'm broadcasting actually from a patio overlooking the amazing landscape of Santa Fe, and the moon has just risen over on my right side. The sun is just going down over on my left side, and during the day today we had amazing thunderstorms and a tremendous amount of rain, but right now it's beautiful. But as a sort of just a housekeeping trip here, I'm going to do this introduction today, and then tonight I'm going to just sit back and watch. I'm going to enjoy the show like the rest of you. I might be able to come on if we have time at the very, very end to kind of show you some things to look at in the night sky. But for the most part, I'm turning the show over to an amazing team that you already know. Let me make some introductions. So Kim Batista is our webmastress. And she is the one that sets up these webinars and gets them organized, keeps the communication going, and we really appreciate that as we go. And also on our staff is Alicia Hyatt. She's with us today. She will be handling part of the program and giving you some updates on some current events and some things going on. Armand Dalla is with us again tonight. He's a student that has been working our shows for almost about 8 or 9 months now. And Alex Blanche, I think a lot of you remember Alex. He's going to be sort of taking a little bit more of a role like I take during the show tonight. And so with all of that, just some quick little housekeeping things. This particular program is a webinar format, and so we don't use the chat function, but you are encouraged to use the question and answer button liberally. So just go in there if you want to make a statement, if you want to say something, if you have a question about something going on right away. We do answer those questions as we're going, and we bring some of those questions to the broadcast at certain points during the program. So please, if you are interested in something that we're talking about, need a little bit further information, please do that. That would be great. We have closed captioning. We use that, and we use closed captioning to kind of take care of some of the our future posting of the broadcast and everything. But it's up to you if you want it on your screen or not, and there's a way for you to turn it off. And we sort of encourage people to use full screen mode. We've got a lot of great images and some videos to show you tonight. So that'll be really helpful and really handy to you. Another thing I just wanted to kind of mention is about 2 weeks ago, I hope you were there, this whole team was up in Flagstaff, Arizona. So we did a broadcast from Lowell Observatory. The rest of the team is back at home and in their home studios. It's just me. I'm gone this week in Santa Fe, and Meg Hufford, usually with our team, is traveling in the Midwest. We're getting ready for classes to start next week. So a week from tomorrow, the 2016 class of new incoming freshmen will be hitting our building. We're all getting ready for that. I'll be back by then, and we'll see where we go from there. And so we're really looking forward to that. Tonight, the main feature is going to be an update on the cameras that are on the Perseverance Rover and what they're doing right now. We'll get to that feature, the main event here in a moment. But I also tonight will give you an update on a couple of other missions. There was a launch last Thursday, very successful. You'll get a sort of a thing on that. And another launch we're looking forward to at the end of August. A little bit more about that later in the program. And so all of us are taking on a role. My job right now is to introduce you to 2 videos just to kind of get you in the mood for the Perseverance rover discussion. Check these out, and I'll be back to introduce our guest in just a minute.
We are starting the straighten up and fly right maneuver in preparation for parachute deploy. The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration. Skycam maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
Touchdown confirmed. Perseverance is safely on the surface of Mars, ready to begin seeking the signs of past life. Looks like we're getting the first image.
This is the most amazing thing. This is what NASA does. This is what we can do as a country.
The ASU Mastcam-Z team celebrating the successful landing of NASA's Perseverance Rover. The rover landing on Mars after a 7-month journey through space. For the past 7 years, ASU professor Dr. Jim Bell and his team have been designing and building special zoom cameras for the mission known as Mastcam-Z. Now, they get to see through their new lenses on Mars.
It's just crazy, you know, it's not every day that you land a robot on another planet. And ASU's cameras are on board, and the engineers at NASA just gave us a great, gentle ride down on the surface, uneventful cruise from Earth to Mars.
The team will now have to wait a couple of days to see how Mastcam-Z is functioning.
For our cameras to get turned on and make sure that they're working right and that they survived that landing okay, that the lenses didn't get too dusty and dirty, and just see how they work. And we got a bunch of test data to take.
Then comes
Excellent. Oh, I haven't seen that for over a year. We actually had a big, huge party, sort of a landing party at the building, and you saw the first part of that was, of course, all the NASA engineers, and they were all cheering, and everything went well. And then we kind of cut to our own cheering because this is a really, really important project for us. And so, but that was actually February 2 years ago, and we thought it's about time, because these projects go on for a long time. It's hard to keep the news in front of you in some cases, but we thought it's about time to give you an update on the Perseverance Rover, at the cameras that we run and operate at the School of Earth and Space Exploration. And we did a little review yesterday with your guest that I'm going to introduce in a moment. And I'm just amazed at some of the things that these cameras are discovering and the research going on. And so you'll get a chance to see that. So I'm going to introduce Catherine Powell. Catherine is a research scientist at the School of Earth and Space Exploration. She joined the Perseverance camera team about 4 months after landing, but she's been an integral part of that since. And she is part of a team we call Payload Download Link team. And she'll have to explain exactly what that means. But if you saw in that little video pounding on the window, and the people, this is COVID time, right? And the people that were inside are the people that are sort of like on this downlink team. And so Catherine, welcome to the program, and I can't wait to see what you have to show us. Thank you.
Thank you for having me. It's been a fantastic almost 2 years, and in Mars time we would say it's been 523 sols. That's what we call a Mars day. That's what day it is today. So we've had a lot of fun. I have just some pictures and some videos to share with you today. Just to give a little bit of an update on what we've been up to on the Mars 2020 project and on the Mastcam-Z camera system in particular. So I'm going to go ahead and share. All right. So the Perseverance Rover and its companion, the Ingenuity helicopter, are part of the Mars 2020 mission. It was launched in July of 2020, and as Rick was just telling us, it landed in February 2021. Perseverance's main goals are, one, to understand the history of its landing site in terms of its geology and how it's been affected by water, and a little bit to understand whether there was ever life present in the crater that it landed in. It also has a very important task to collect samples that we hope will one day be returned to Earth. It's the first rover that has that capability to collect and cache those samples. And so I'll tell you a little bit more about that in a few minutes. Perseverance is about the size of a minivan. It has a nuclear power source, and it can drive hundreds of meters in a day, much further than previous rovers that we've sent. It has many fantastic instruments on it, including a subsurface radar, a weather station, several spectrometers that can tell us what its rocks and soils are made of, and 23 cameras. We use these cameras for all sorts of engineering and science purposes. But the camera system that we're involved with here at ASU is this one called Mastcam Z. It's heritage from Mastcam on the Curiosity instrument, so called because it's located high up on the rover's mast. It's a pair of cameras. It has a left and a right eye, just like we do, so it can see in stereo. It can also see in color, in visible wavelengths that our eye can see, and a little bit into the infrared as well. And Mastcam Z is new and special in that it has a phenomenal zoom mechanism on it. And it's able to get great detail on faraway landscapes and on targets that are right in front of the rover. So it's been able to take fantastic images, even compared to great ones that we've gotten from previous missions. The principal investigator of this instrument is the man you just heard from in the Hawaiian shirt, Professor Jim Bell from CC. And he leads a team here at ASU that I'm part of that does half of the operations work for this camera. And so we work with our colleagues out at JPL and our colleagues out in San Diego to operate this instrument. And basically our job is to receive the images and data when it comes back from Mars from this instrument, and to process it and to make the images into beautiful panoramas for all of our science team to use. So we sometimes get up very early in the morning to do that. And it's always really fun to get to see some of those great pictures from Mars. So where did we send Perseverance? We picked a really fantastic location that wasn't accessible to previous missions. We have improved landing technology that allowed us to pick terrains that were not as smooth and flat, and actually had some hazardous features in it that Perseverance had the technology to be able to avoid. And so with that new technology, we were able to land in Jezreel Crater. Jezreel is an ancient impact crater that was once a crater lake. As you can see in the top left of this orbital 3 image, the dry riverbed that once fed this lake. And as that riverbed entered into the mouth, it deposited rocks and sand and sediments at the mouth of that river, and eventually built up a river delta. We're interested in this delta because it's a great way to potentially preserve organic material. And we can see a record of water altering this area. And so we landed in February of 2021 over here, this landing site, on the floor of the crater. So still a relatively flat area. And we spent some time exploring the floor of the crater and caching some samples of that crater floor, which are some of the oldest rocks that we're going to see with this mission. Then we embarked on what we called a rapid traverse, a very quick series of drives around this sand field and over to the delta. We were very interested in reaching the delta quickly and trying to understand its layers relationship to one another so we could pick which areas to sample. We really made this drive very quickly. Perseverance has this capability to drive hundreds of meters a day because it can actually make some onboard decisions about avoiding hazards as it goes. And so last spring, we reached the delta. And since then, we've been exploring around the edges of the outer layers and doing quite a bit of sampling of the rocks here. So where we are right now, we can zoom in on the delta, is we're in an active sampling campaign at an area called Hogwallow Flats. And Hogwallow Flats is this bright strip of sedimentary rocks at the base of the delta cliff here. And so we've been here for several weeks now, working on a sampling campaign. And here's what that looks like. This is our Mastcam Z mosaic of the area that we're still located in today. So this mosaic is made up of many images that Mastcam Z took that have been stitched together. And then it has been color enhanced so that you can see some of the fine differences in color that you wouldn't get if you were looking at it in an approximation of your naked eye. It would look very red and dusty. And we've done a little bit to help draw those differences in this color. And you can see this is the same Hogwall Flats material. There's this bright sedimentary layer that's sitting out there at the base of that cliff. And in the foreground here, you can see our sampling that we've actually done here. These are the drill holes and the abrasion that we did on this rock here called Wildcat Ridge. And I'll show you a better view of that in just a moment. Yeah, so sampling and coring is very important to the Mars 2020 mission. We've sent several missions to Mars, and we send better and better technology each time. But we're really at a point where we can gain a lot of value from bringing samples back to Earth. We're always going to have better technology here in our labs than we can send to Mars. We can also choose to keep samples and analyze them as better technology comes out decades down the road, as was done with the Apollo samples. And so we hope to be able to do things like precisely age date these rocks, which is something we can't do well at Mars. And also to potentially do experiments here that can tell us whether these rocks contain organics and whether those organics potentially might be signatures of past life. We think any life that might have been on Mars is probably very simple microbes, and it's not something that would be easy to detect with a rover. So we'd really like to bring some of these back. We're also planning to take samples of sand, regolith, that we find on the surface, and we've ended up with samples of the atmosphere as well. So these samples, you can kind of see the geometry here. You end up with a core that's a few inches long and about 12 millimeters in diameter. And it preserves the structure of the ground that you actually drilled. So it's a solid core for the most part, unlike the powders that Curiosity gets. And so these are going to be sealed and left behind on the surface for a future mission to pick up. If you look on the right here, this is what one of those samples looks like when it's still in the coring bit. So this is before it's been checked out and sealed. This is a Mastcam Z image of the most recent core that we took called Bear Hollow at that Hogwall Flats location. And so that rock that you're looking at is hopefully one day coming back to Earth. And you might be lucky enough to see it in a museum someday. Or, you know, if there are kids out there, maybe you can grow up to be one of the scientists that analyzes this sample when it comes back. It's pretty cool to be looking at. It's always great when we get a new one, and this is just the most recent one from last week. So, and that's just all of the drill hardware in the background that makes it possible to take this core, and then the brown spot in the middle is the actual rock itself. And so what we're going to do with these samples is something that NASA has been working very hard on, and they recently made an announcement just a couple of weeks ago. The plan has changed a little bit, and that Perseverance is going to be a really active part of it. They are building on the success of Perseverance and its helicopter buddy Ingenuity to retrieve these samples. So the new plan involves Perseverance being actively involved in returning the samples to a lander platform that will be able to send them into space and eventually back to Earth. There's also now, they've announced concepts for sample retrieving helicopters. So the little helicopter that was sent with Perseverance has really overperformed and exceeded all expectations. It's still alive at this point in the mission when it was only supposed to be around for a month or two. And so they're hoping that Ingenuity-like helicopters might be able to retrieve sample tubes from locations on the surface. And so that's all currently in the works. We're doing some scouting with Mars 2020, in particular with NavCam and Mastcam Z, to look for areas that might be safe to land these craft that are eventually going to take the samples off the Martian surface. And so this is pretty exciting and an evolving story for sure that we'll be keeping an eye on. And so here is what our most recent sampling location looks like. Hogwall Flats. And so we're going to start off with an unaltered rock as we found it and progress through an abrasion where we just grind away part of the surface, and then 2 drill holes where we actually core into it and retrieve those samples that will be returned. And so this is a 3D model that was built with Mastcam Z images. taking advantage of those stereo capabilities of overlapping images. And so now you can get a little bit of perspective on how big these drill holes are relative to that abrasion and how much we really disturb that rock when we take this sample. This is always pretty fun to look at. And you can get a sense too of the sort of relief of the rocks in the background and the contrast between the sand overlying all of this and this really light toned rock. This is a really exciting sample for us because it's our first confirmed sedimentary rock sample. We think that the samples we were taking on the crater floor were igneous rocks. And we really do think that these sedimentary rocks saw water at some point. And so it's really cool to be getting these in particular and getting sort of our first taste of the delta at this location. And there's lots of models like this out there. The graduate student on our team who made this, Christian Tate, has a Sketchfab site where he makes a lot of really awesome models from Mastcam-Z and some of the other cameras on the mission. So I certainly encourage you to check that out. It's pretty cool. And then just one other thing that I wanted to share from Hogwalla Flats that was just caught my eye the other day. This is the ridge just right up above Hogwalla Flats. And so if we've been down here sampling, this is this ridge up here that's just above us. And you can see in this Mastcam-Z image how much darker these layers are and how much blockier it is than everything below it, how those blocks are just eroding away down this slope. And so this is also giving us a taste of what we're going to see further along at the delta and other areas we might maybe be able to sample in the future as well. So this is called Rocky Top for obvious reasons. It's just one of my favorite images that I've seen over the past couple of weeks. I wanted to share. I just have a couple more minutes. Just a little bit of where are we today? So on the right here is an image that was actually taken yesterday and came down yesterday of this ridge. And this is just in its sort of raw image format. If you'd like to see raw images from the mission, including Mastcam-Z, NASA has a website for that. And if you honestly just Google Perseverance raw images, this will also come up. And you can see our images coming back almost in real time. And if you want the really authentic payload downlink lead experience, you can get up at 4 in the morning and go look for them, like we do. But yeah, so far we're 523 sols into the mission. So again, about a year and a half. We've driven over 7 miles on the surface, all the way across that crater floor to the delta. We have 12 rock samples that we've collected so far. We also have several witness tubes that we've taken that we're intentionally going to be empty to understand how they've been altered by going to Mars and coming back. An atmospheric sample, and more to come, certainly. I haven't got to talk too much about Ingenuity. We did bring our little helicopter with us. It is still flying. It's flown 29 flights so far, and it's now in a sort of winter stasis, waiting for things to get a little bit warmer so that its power situation is a little bit better, but it's still out there and kicking. Let's see. A couple more, just to close with a few fun things that we've seen along the way in the last year. This is not a Mastcam-Z image. This is actually an image taken by Ingenuity. You can see this little shadow here on the left. This is our entry, descent, and landing hardware that we brought to Mars. This is what got us to the surface, or at least part of it. Upper left, you can see our parachute. You can kind of still see the red and white stripes a little bit if you look under the dust. And then that's just connected to something called the back shell, which was what was protecting the rover and the landing apparatus as it was coming down. And you can see that it has hit the surface in spectacular fashion, did exactly what it was designed to do, got the rover safely to Mars. But we drove relatively near this a few months ago, and Ingenuity was able to fly even closer and get us these really cool up-close pictures. So this looks like a catastrophe, but this is actually working exactly as designed, which is something really cool that we saw along the way. And then the last thing that I have is back to a Mastcam-Z image. This is one of Mars's moons, Phobos, and it is crossing the sun in this video. So Mastcam-Z actually captured this. We were able to find out that Phobos was going to be in this configuration. It doesn't quite make an eclipse because of its small and odd shape relative to the sun at this distance, but you can see it transiting all the way across the surface. And so this was something really, really cool and really special that we were able to see. So I'm just going to let that play just one more time before I shut it off. But yeah, so we do actually, while we're focused a lot on the geology of Mars and bringing these samples back, we do take opportunities to look around us and to observe the sky, observe the atmosphere, and understand our environment as well. In this case, we're even doing a little astronomy, if you were. So, right. I think that I will end it there. Thanks for listening.
Perfect. Thank you so much, Catherine. So I just, just while I think what we might do is we're going to launch a few poll questions for everyone. I think Alicia or Armand's going to do that, but I also just kind of want to take a little bit of time to discuss some stuff while we do that. I'm going to have Alicia launch those real quick.
Thank you, Alex. I'm going to go ahead and launch our first poll, which has 3 questions, so make sure you answer all 3. How long is a day on Mars? How far has the Perseverance traveled since the mission began? And how many rock samples have we collected for the future return to Earth? So go ahead and answer those, and I'll turn it back to Alex.
Thanks, Alicia. I just want to say, one, you answered a couple great questions that people were already spitting out in the audience, like what a witness tube is for, which I didn't even know that. I was kind of, that was very interesting. But and you briefly kind of mentioned that waking up really early for these images, but like, what is kind of the day in life? What does your typical day look like for this downlink project lead and having to work with all this data for something that's so far away and literally on a different planet?
Yeah, it's really fun. I'm actively on shift about half the time because there's about 4 of us and 2 people staffed at a time. And so we're kind of subject to whenever the data comes back from Mars that we need to react to. The whole mission as a whole has a cycle of planning, sending commands to the rover, and then waiting for information to come back about what images we actually took, how far we drove, what the rocks around us look like wherever we drove to. And we're waiting on that information on the downlink side so that we can make sure that everything is good and tell the people planning the next commands, hey, here's your status, go away and have fun. And that comes to us from actually satellites that are orbiting Mars. So Perseverance and the other rovers communicate with satellites as they go overhead. And so they have to wait for a relay essentially in order to send information back. And then we wait for that orbiter to relay information back to us on Earth in the Deep Space Network. And that because a Mars day is a little bit longer, and I won't spoil it, but it's a little bit longer than an Earth day. Time is always moving relative to say Arizona or California and Jezreel Crater. And so sometimes it's very convenient for us what time it is for Perseverance, and sometimes very inconvenient when we get that data back.
So you have to be a little flexible with the schedule. You have to go off the robot. That's good. And let's see. The one thing I had a quick question. You showed that wonderful little video of Phobos transiting the sun. So does Mastcam-Z have solar filters that it can use? Like, because I was aware that most cameras, if they look directly at the sun, it's fried. So how does that work?
It does, yeah. It has a filter that it can do that with. So, and we observe the sun pretty regularly for atmospheric science.
Oh, wow. I didn't know that. Well, perfect. Alicia, do you want to announce the poll results? Because it looks like kind of everyone got them in right now.
Yes, I'm going to go ahead and end that poll. And I'll share the results. Perfect. So thank you so much. It looks like we had a large number of audience members participate. And I don't know if we all 3 want to go through these and go over the answers, but how long is a day on Mars? So, Catherine, do you want to answer that?
Yes, I should have given spoilers. Yes, it is 24 hours, 37 minutes, so just a little bit longer.
Perfect. So definitely a hard question. Looks like 33% of us got that right. How far has Perseverance traveled since the mission began? We went over, or you went over this in your presentation.
And it looks like a lot of them got it. 11.8 kilometers. 66% of them all got it, which is great.
Doing great. And then last but certainly not least, how many rock samples have we collected for the future return to Earth? And it, again, looks like a majority of us got this right at about 70%. So great job, audience. Thank you so much, Catherine, for that wonderful presentation. And I will turn it back to Alex to continue.
Yeah, perfect. I know we have some, I know you answered some great audience questions we had already about the witness tubes, but I think Armand's going to come, and if there are any other questions that we have. Armand, do we have any other questions?
Yeah, we have a few great audience questions here. One from Stosh. Has there been any surprises so far for the mission itself?
Yeah, absolutely. I think we're always surprised about seeing a new area up close that we've only seen from orbital imagery. And yeah, so definitely in the composition of rocks and in the things that we've seen. We've also had some interesting surprises lately as we've seen bits of debris from our landing system that we weren't expecting. They're actually, I don't know if you've seen the things about string on Mars, but there are actually pieces of that have blown by in the wind, and we definitely were not expecting that. So yes, every day is a new adventure.
Awesome. And Stephen is asking, does ASU have a satellite dish on campus to receive the data from Perseverance? Or how does the data get all the way from Mars to IST before you're at ASU?
Yeah. So it goes to the Deep Space Network, which is a system of satellite dishes that are positioned around the world so that something out in space can always access them. And then that information goes to the Jet Propulsion Laboratory before it comes to us pretty much just over the internet. So.
Awesome, great. Thank you so much, Catherine. And yeah, keep asking questions in the Q&A section, and we'll get to answer them either live or in the Q&A section itself.
Yeah, perfect. Thank you so much again, Catherine. It's wonderful to have an update on the Mastcam team and get to hear the personal experiences, and a wonderful presentation. And again, thank you so much from us in the team and from the audience as well. I really appreciate that.
Alrighty, thank you guys.
Thank you. Okay, so now we're going to go into a little bit of a different thing. You're still with me. We're going to talk about two kind of current events astronomically. We got the Perseid Meteor Shower, and we got the Sturgeon Moon. We'll talk about the Meteor Shower first, because I'm sure some of you are going to be really interested and want to see how you can find those. So we're going to start out in my Stellarium program, and we're going to start, here it is right now, and we're going to skip forward a little bit. The peak of the Perseid Meteor Showers is going to be the 11th and the 12th. The bad thing about this is that, so in a few days it's going to start peaking, but the bad thing is that we got a great big moon, a nice full moon out here that's going to be messing with it as well. So you can see right here, we have our Perseids, or I think it's, I don't know where they are right now, but they should be up there. But we have the meteor shower, but we have a full moon, a very, or almost full moon, but still a very bright moon that's going to be popping up. And so these asteroids are going to be almost washed out. So unfortunately, even though we're kind of right in that peak season during the 11th and the 12th, it's going to be very bright. So unless you're in a very dark sky area, you have nice optical equipment, it's going to be tough to see them because they're going to be washed out by that moon. And even in areas like here in Tempe, it's going to be very, very difficult because even at the brightest, they're still very dim. But you can see them, they're about 150 to 200 an hour. That's kind of the peak of this. But the thing is that, again, with that full moon, this kind of nearing that Sturgeon moon, it's going to be very, very hard to see, difficult to see. So you might be able to see them, but it's going to be difficult. The thing is, actually, the Perseid meteor showers, if you don't know this, they're actually not just asteroids or out in the orbit of Earth. They're actually associated with a comet. A lot of comets actually leave behind particles as they fly through the solar system, and as the Earth goes around, it can pass through these large clouds of dust and gas and ice that are left behind. And so this is actually from Comet Swift-Tuttle, the Perseid meteor shower. So this is actually kind of the remnants of that. And so as we pass through that big kind of trail that comet left, we get to see these meteor showers once a year. But the moon has other plans. The thing is, the Sturgeon Moon's coming up. This is a full moon. If I remember correctly, it's actually one of the. It's a big. It's actually going to be quite a fantastic moon. Sorry, but the Sturgeon Moon is actually going to be this on the 11th, tomorrow. It's the last supermoon of the year. So this is kind of when the moon's closest to that point in orbit where it's really close to Earth. That's kind of the periapsis, some people call it, but it's really close to Earth, but it's starting to move away from that point, and so these moons are going to get a little bit smaller. It's not really noticeable. I'm of the opinion that supermoons really, it might be a little heretical to say this, but they aren't that super. The difference between moon really far away and really close is only about a few percent. So even though supermoons are always kind of a neat thing to check off on your list of something you get to see, this is the last one of the year, and it's probably not going to look much different than the next full moon. It's called the Sturgeon Moon because it's part of this kind of seasonal titling of moons. It's like the harvest moon. It's called this because the giant sturgeon of the Great Lakes were caught during this part of the summer. So they named it after all the sturgeons that they were catching. So that's why it's called that. It's kind of in relation to the harvest moon. We like to name a lot of moons like that because the moon, like a lot of things in astronomy, have served great for calendars. So look out for the Perseid meteor shower. Well, I wouldn't say look out, but if you're out there, and you might be able to see one, but the moon's going to be very tough competition. And then also the Sturgeon Moon, the last supermoon of the year, is going to be up tomorrow night as well. So look for those things. And then I think, Rick, did you want to talk about stuff as well?
Yes, I do. Sorry about that. I just was getting something set up and I missed my button here. So you can see things got kind of dark where I am. And so just in case you missed the very beginning of the show, I'm actually sitting on a patio in a beautiful setting looking over the horizon in Santa Fe, New Mexico. And great day today. I went hiking with Luna. We went on a 3.5 mile hike up to a peak that was about 9,600 feet. And then we came down. She got to play in the creek and do all that kind of stuff. So we're sort of like just finishing our day. It's very, very dark. I wanted to just kind of, if I can, I'm going to show you something. We haven't done this for a while, and I wasn't sure whether technology was going to work here or not, but I'm going to share screen with you a little bit and show you a thing we sort of we call it Planet Watch, among other things. And I think I got enough bandwidth here to sort of like make this work. But if you can sort of see on the screen there, I've got a little simulation of the solar system, and these planets are blown up quite a little bit. This isn't their relative size actually in space. This isn't really what they look like, but they are. It gives you a really good sort of a good view of their relative position to each other. And so you see sort of in the very front part of in the middle of the screen there, circled by the blue orbit, that's your Earth. And the sun is in the middle. I have it turned down quite a little bit. Like I can sort of turn it up a little bit. And yeah, let's leave it there. So I dimmed it a little bit because I thought it would be in the way. And if you've watched this before over time, remember several months ago, we were getting you guys up in the early morning and we were looking at that parade of planets. It was sort of like just from the horizon just before sunrise and trailing off into the sky. And it was really beautiful. And I explained at the time that everything on the right side of the screen is what is a morning object. So if on that side of the sun, it's prominent in the morning. If it's on the left side of the sun, it's prominent in the evening. That should tell you that tonight you should be able to see Mercury right on the right side in the evening, right at sunset. And I'm going to show you another little chart where you can see that. And so you'll see the sun just after sunset. A star-looking object will be actually the planet Mercury. And Venus is actually a morning object still, but it's just about to move behind the sun from our perspective. So it's getting closer and closer to the sun, and then therefore closer and closer to the sun's glare. Here's the really cool news for the rest of the year. I'm just going to swing way over to the right side. And so for planets that pass behind the sun, it's pretty easy to understand that they're going to be sort of seen in the morning, and then they're going to bury themselves in the dawn, and then we will see them in the evening. But there's something else going on. this Earth is passing sort of between the sun, and you can see Jupiter in the background, and then Saturn in the background as well. And you can also, if I kind of have the view just right, you can see Neptune in the background as well. And what happens in this particular case is they don't pass behind the sun and then appear in the evening. They actually sort of start moving around us, and so that they appear in the middle of the night. So I'm going to reset over in this direction so that the Earth is between us and the sun. Sorry, this is going to be just a little bit jerky because I'm kind of in a compromised bandwidth situation. But now you can see the Earth and the sun in the middle of the solar system in the screen, and the great marvelous planet Saturn is just kind of like right behind us. That means that Saturn is moving into a position where it'll be as highest in the sky as it can be right at midnight, and that will be very soon. Lucky for us, it's actually starting to appear in the evening sky. So I'm going to stop this share for a moment, and then I'm going to share something else with you on a different kind of computer. Watch me do this if I can do it. This is actually sort of a little view of your night sky tonight. And I think you've seen this view before. What I use is a little planetarium program on my iPad, and this is called Sky Safari Pro. These are programs you can get. The one we were looking at before, where it was simulating the planets, that's a little bit harder. That's for planetariums. It's called Digital Sky. This particular one is basically for you. And everything in the blue is what is visible above the horizon at 8 o'clock tonight. So theoretically, once we close down, once we say goodnight, and once we say we'll see you in a couple of weeks, you could go outside and this would be in your sky. Now, this time of year, of course, it's monsoon season, so we don't get a lot of sky. We don't get to see a lot of this stuff, but that doesn't mean there's an excuse for not going out and trying, right? Go out and look every night, just you can at least judge the sky cover. You can see what's going on and see that. Let me just show you this. I'm going to try to relate a couple of things. Do you remember Alex was saying that a big, huge, nearly full moon is just coming above the horizon now? Tomorrow night, that will be full. That's the Sturgeon Moon. He just talked about that. But if I can also show you, remember on the screen we showed before, Saturn, you can see it just sort of down below the horizon towards the left. And this is at 8 o'clock. If I move ahead just an hour or two, let me just move ahead to 10 o'clock. Now Saturn is well above the horizon, and so is Pluto in the background over there. And very soon, there's Neptune, right, sort of next to the horizon. And then very soon, Jupiter is going to be coming up. So instead of going around, this to sort of recap here, instead of going around behind the sun and then reappearing in our evening sky, what's happening with these planets is they're rising a little bit earlier every single night. As we move around the sun, we change the position to them. So they are starting to become evening objects instead of morning objects. So no more are we going to be asking you to get up at 4:30 in the morning and go look at these planets. Now we're going to start sort of like alerting you to when to watch for the planets in the evening sky. That's going to be a lot easier. I also wanted to point out one more thing. I'm going to center on the screen. You can see Saturn. Actually, I can just sort of like sketch this a little bit here. I think I got this. Let me change my pencil color to white. And so this is Saturn over here. It's kind of above the horizon for me right now. For you, it'll be in about a half an hour, and you'll see it. This is Jupiter down here. Remember, it was only a year ago that we witnessed and we had a special broadcast for that great conjunction. Remember that? That's when Saturn and Jupiter were right next to each other in the sky. Well, a year later, a whole sort of cycle later, the Earth has moved around the sun completely, but also Jupiter and Saturn have changed position in their orbits. So that conjunction of last year that we said was a rare thing and we're not going to see it for a long time, sure enough, we're not, except we will still be able to see those two planets in the night sky. And so that's the big thing to look for. I know it's troublesome right now. The moon will move out of the way. in the next couple of days. So let me just sort of show you that. If I go ahead one day, here's the Saturn and the moon. This is at 10 o'clock tonight, and they're above your horizon. If I move ahead one day, the moon will be passing right next to Saturn. I can't tell you, I think that's going to be the glare of the moon will sort of like, and this is the full moon. I think it'll make Saturn disappear, but the very next night, it'll start moving out of the way. Certainly by Saturday this week, I think it would be a great time, especially if it's not cloudy, if it happens to be a clearer night, to kind of start to get a view of Saturn. The other reason to call attention to Saturn is it's a beautiful object in telescopes, even binoculars, but a small telescope, a hobby style telescope, an amateur telescope or something like that. Saturn is one of the most amazing objects to look at in our night sky, because truly you can see the little disk of the planet and the rings surrounding it. So to wrap that up, here they come. All of those planets that were morning objects 3 or 4 months ago, and we were sending them out in the morning sky. No longer that. Now they're starting to sort of appear in your evening sky, and they'll become, for the rest of this year, all of the planets in succession will start to appear on the horizon just after dark. And by November and December, all of the planets we saw in the morning sky will be in the evening sky. We'll be talking about them then. Be a lot easier to see then. So that gives you something to go look for. As a reminder, I'm going to say, let's wait for 3 or 4 days. Let's wait until Saturday. Let's let the moon move by. Let's get it out of the way, and then start looking for Saturn directly into the southeast and see it appear in the sky. All right. And that's it for me. I'm going to turn it back over to the team. A couple mission updates. Thank you.
Alrighty, I think that's me. I'm gonna go ahead and share my screen now. Alrighty. Well, welcome to current events this week. We have a couple really important things to discuss, some that kind of already happened and some that are going to happen. So first we have Luna Map. I know that we've talked about it on the show before, but just in 18 days from now, we're really excited to announce that Luna Map launches, hopefully, fingers crossed, August 29th on the NASA Artemis 1 spacecraft. Once it's been deployed, Luna Map uses a series of lunar flybys on its ion propulsion system to enter what we call a captured lunar orbit. And so once this happens over the following months, Luna Map uses its ionic propulsion system to then grow closer and closer to its orbit, or get closer to its orbit, excuse me. And so it'll be focused on that south pole of the moon. And so it'll capture science for a minimum of 2 months, but hopefully a couple of years. And then when it's done capturing science, it will be followed up by a spacecraft disposal on the lunar surface. So keep an eye out for the next couple of weeks, 2.5 weeks, while we look forward to the Luna launch. With that being said, I'm going to turn it over to Armand to take over our next part. And Armand, I'm going to reshare because I did it with sound.
All right, thank you. Well, let me go ahead and get started in the meantime. So we've talked about how ASU is involved in lots of NASA missions. Just in this presentation, we talked about how we are part of Mastcam Z on board the Perseverance Rover on Mars. Alicia just talked about Luna Map, but just recently, last Thursday, actually on the 4th of August, as you can see on the title of the video, Korea launched their first lunar orbiter, and it's called the Korean Pathfinder Lunar Orbiter. And on the orbiter itself, there are 6 science instruments, and one of them is called Shadowcam. And that was designed here at ASU by the same team that worked on the Lunar Reconnaissance Orbit camera. And Shadowcam is the main mission objective is to identify the distribution and accessibility of water ice on the moon's poles, specifically in what we call permanently shadowed regions. And like the name suggests, these regions, they never see any sunlight, regardless of what time of year it is, where the moon is in its orbit. These regions are at the very bottom of very big and very deep craters on the poles of the moons. And they're only illuminated from light reflected from the surrounding environment. So Shadowcam, it's about 200 times more sensitive than the narrow angle camera on board the Lunar Reconnaissance orbiter camera. And it's going to be looking right deep into the shadows, into the permanently shadowed regions, and to look at the distribution of water ice on the poles of the moons. And we talked about how it launched last Thursday, and it's currently on its way to the moon. I believe they've already started up the startup procedures. We're receiving data from the spacecraft itself, and it should be launching into lunar orbit in about December, and we should be getting the first science data back from it in early January. So that's it for Shadowcam and LunaMap and current events, and I'm gonna hand it back over to the team.
I think that's it. Rick, do you want to do closing words or do you want me to?
Well, we have a handful of resources that I see posted here. And so let me just double check in chat. We wanted to make sure that people have, we sort of, so I'm going to just sort of suggest to you that there are resources for everything we talked about today. A couple for Mastcam Z. Remember, you can actually go to the NASA raw image site, and we will make sure that that is posted for you after the program. You'll get a letter or an email from Kim, just sort of thanking you for arriving. I can see, and then you can, and I see it posted in the thing now. So you can kind of look at that. But these missions, I guess one of the things I wanted to talk about a little bit is that they last for a long time. I heard Armand mention, for example, the Lunar Reconnaissance Orbiter. That is a spacecraft that has been going around the moon. It's actually been operating for almost 13 years. And so the missions that sort of that we are involved in is the Lunar Reconnaissance Orbiter camera. And those have been had extended missions about 7 times now. So we've gone we did our regular mission, and then it just keeps going, and we get more time, and the spacecraft is still working, and we keep doing that. So if you want to keep track of these, you're not going to necessarily see them on the news every day. You should, if you want to, sort of get used to going onto the NASA website, looking up these missions we're talking about, follow along yourself. Catherine gave an incredible presentation tonight, and she was telling you sort of the progress of the Perseverance Rover as it's moving around the surface of Mars. This is happening every day, and this is not something you read in the newspaper every day. If you want to know about it, you either have to kind of touch base with our show, or you have to go to some of these resources to do that. So follow Shadowcam. That's a little bit harder to follow because it's not a NASA mission. Remember, that actually is a Korean space mission, and that's kind of important to keep track of it that way. So if you want to follow these, that's the way to do it. So these are resources we like to supply to you. Watch for them in your email after the program, look those things up and see where we go from there. So with that, I think we are going to end just a couple minutes early tonight. Thank you very much. I know sometimes we go a little bit over. My wife would say we go over. She's standing right here. My wife would say we go over kind of quite a little bit. I wanted you guys to all be able to say goodnight to Luna too. She's over here. Say, there she is. Hey, Luna, can you tell that I'm bribing her with a little milk bone? Thank you. She's had a very, very big day today. Thank you very much. We'll go hiking again in the morning. So with that, we're going to be back with you 2 weeks from now. I'll be back on campus, and sort of things will be back to normal. School will start. We will be looking forward to the next big thing for us is that Artemis 1 mission. So remember, we talked about that. That is the one that has the LunaMap. LunaMap, I've been watching the progress of this for years because they built the device in our building. So right there off of the main lobby, look through the little windows, you can see them building this thing. So I feel like I'm vested in this thing. I had nothing to do with the project, but I feel like this is something really special that came from us, was built at ASU. It's what they call a secondary payload on Artemis 1. So we've been waiting for that big project to launch in order to get our little spacecraft out into space. So it looks like it's finally going to happen. So we'll give you an update about that in 2 weeks. The actual launch date, as you sort of heard tonight, is August 29th. And we'll see how that goes. So lots of stuff coming up. We've got a great end of the season, end of the year. And I'm going to just kind of ask Kim Baptista just real quickly if we've covered everything. I know things are a little bit disjointed because I'm trying to broadcast from a patio.
Good. I was going to say you should come to Florida with me in 2 weeks.
That's right.
Broadcast
So
from Florida.
Kim's actually going. So in fact, you'll be in Florida during our program 2 weeks from now, right?
I will.
So, and this, Kim, I think I know this, but this is your first launch, right? You've never like gone to
Yeah, no, it's my first one. So I'm going to be exhibiting and I'm doing it all in 2 weeks. So
and Kim is responsible for a lot of the press relations and all the sort of the activities amongst the team that put together the spacecraft and do that. So that's great. Actually, let's plan on this. We can't plan on it now because she doesn't know what she's going to be doing specifically in 2 weeks, but hopefully, Kim, you can sort of join us and we can do a regular program and you can tell us all about what's going on in Florida. So that would be super.
I'll be at KSC, so I'll tell you how hot and humid it is down there.
We'll be back in hot and humid Phoenix while you're there. So very good. Well, thank you. Well, thank you everybody for indulging my little sort of my trip. I sort of we're going to get back to it, and we're moving on to another location tomorrow. Going to a little wilderness archaeology conference called the Pecos Conference. That's sort of part of our trip here, and so Luna and Jackie and I will be going up to a place called Roe Mesa, spending a couple of days there, and then we'll be back home next week to get ready for school starting. So thank you very much for attending tonight, everybody that logged in, and please keep watching the night sky. Just don't worry about the clouds. Go check it all the time. The clouds are always moving in and out. Sometimes you get a clear view of some amazing things in the night sky, even this time of year. And we'll see you in a couple of weeks. Thank you, everybody. Good night.